Okay, the problem I have here, the system consists shown of continuous cable AC and pulley B that rides on the cable. Force F with the magnitude 300 pounds acts on the center of the pulley B in the direction shown. Determine the magnitude of the tensile forces in cable AC and the angle theta as well. So what we need to start off with is the free body diagram. You always want to start with the diagram showing the forces and the action and the point at which they act on. So let's start again by drawing the axis, the x and the y. Okay, there we go. And then we have a force going down from the center of the pulley right there. So we can say that is from here. Let's name this point B. Okay, and that's F is what, 300 pounds. And also we have another tension here away from the point. So that is going straight here. And here we're neglecting the diameter of the pulley. We are assuming all the forces are from the center of the pulley. So here we have 80 degrees, and this is tension AB. And also we have tension AC right here. And that is all we have for the free body diagram. But also we need to make note of one more thing. The tension and the pulley are equal in both directions. So tension in AB is also equals to tension AC. So we can rewrite this tensions just as T, because solving for one will give us the other one. So now we can do the sum of forces in the x direction, equilibrium. Sum of forces in the x direction equals to 0, and we're assuming right is positive. So here we have TAC going here, and don't forget to put your angle right here. There's an angle there. So TAC is going to the right, so we have just a T, since we don't want to write TAC or TAB because they're the same as T. So we write T, and then TAB here is also represented by T, but it's going to the left. So this would be T cosine 80 degrees because we're looking for the X component. And also your force is minus 300, but to find the X component here, this will be a sine because this is opposite of the angle. Okay, what happened to my, okay, there it is. So this is opposite of the angle, so you want to use sine of theta, which we don't know yet. Okay, and now we need to also set up another equation for the sum of forces in the y direction, assuming up is positive. So the sum of forces in the y direction, here we're going to have t sine theta because we want the opposite right here. So we need to use the sine of the angle, t sine 80 degrees. No, I said theta, that's 80 degrees. And also this is going down, so this should be minus 300 cosine of angle theta because we want this portion over here. Well, the t here has no y component, so we can just say it's a 0. And now we can solve for t in one of the equations. Well, in this equation we have a sine theta, so either one will work. But since we already have this one in the bottom, let's just go ahead and solve for t right here. So solving for t right here, we have t sine 80 degrees equals to 300 cosine of theta by moving 300 cosine theta to the other side. Now we can divide both sides by sine of 80 degrees. This cancels out over here. So we have t equals to 300 cosine theta over sine of 60 degrees. Well, now that we have t, we can go ahead and plug back the t into the first equation. So let's do that right here. So plugging back t into the first equation, we have 300 cosine of the angle over sine 80 minus 300 cosine of theta cosine of 80 degrees, dividing it by sine of 80 degrees minus 300 sine theta equals to 0. Okay, now we would be able to solve for theta. Well, first of all, what is cosine theta over sine theta? Cosine, oh, this is 80 degrees. Cosine 80 over 80. Well, that gives us 1 over 10 because sine over cosine is tangent. So now we can write this as 300 cosine theta. Well, since this are common in both of them, we can factor out that and have 1 minus cosine of 80 degrees here minus 300 sine theta equals to 0. Okay, now we can move this over here to the other side, makes it positive. So we have 300 cosine theta over sine of 80 degrees. 1 minus cosine of 80 degrees equals 300 sine of theta. The next step here is to divide both sides by 300 cosine of theta, and you're going to see why, because of the combination we have here. Cosine of theta. And now we can see this cancels out above, and also 300 cancels out here. But this is the main point. This is in order to get sine theta over cosine theta to become tan theta. And now we have 1 minus cosine of 80 degrees over sine of 80 degrees. Now, in order to find our theta, all we need to do is find the arc cosine. Sorry, I meant tan. Tan inverse of 1 minus cosine 80 degrees over sine of 80 degrees. And plugging that into your calculator, that gives us 39.5 degrees. So well, now we have the first part, which is theta. We solve for theta, but what do we also need to solve for? We also need to solve for the magnitude of the tensile force in cable AC, and that is T. Well, we have a relationship for T and theta, and that's right here. That's a relationship for T and theta. So we can go ahead and plug in theta into our T equation. So that gives us 300 cosine of 39.5, substituting our theta for the angle we just solved for, dividing it by sine of 80 degrees. So plugging this in your calculator as well should give you 235 newtons.